In this lesson, we are going to study about the chain rule of differentiation. So, my success criteria is to find the derivatives of composite functions applying the chain rule of differentiation. Here we are going to see that how can we apply the derivative rules by using the different laws of differentiation along with the simplification. Now, the first question comes in my mind that what is meant by composite functions, because we are saying that we can use the chain rule to solve the composite functions or to take the derivative of the composite functions. So the composite functions are the functions which contains the inner and the outer function. So if we have any function containing the inner and the outer function, it is said to be composite function. What do I mean by that? So for example, write down a polynomial function. So I'm writing an expression x square minus 2x plus 3. So it is, if I write here f of x, so it becomes the polynomial function. Now it is a simple function, but if I just raise a power of anything, let's suppose 2, 3, 4, 5, let me just raise the power of 100. Okay, so now it becomes a complex function. Why? The function which is written inside the bracket, it is said to be the inner function, and the power is said to be the outer function. Similarly, if I have any function inside the radical sign, okay, so x plus 1 for example. Now again I have a linear function which is enclosed inside the radical sign. Now this radical is actually the outer function, and the function which is written inside the radical sign is said to be the inner function. Now you can also write this in a shape of the power, like write in the bracket x plus 1, and I know that square root means the half power. Okay, let's write one more function. So we can write it as f of x equals to, we know a trigonometric function sine x, right? So it is a normal basic trigonometric function. But if I just write as 5x, sine of 5x. So here I will again contain an inner and the outer function. The angle which is written after the sine, cosine, tangent or any trigonometric value. So it is said to be the inner function, and this sine and cosine, this one, it is said to be the outer function. Now same kind of the thing, one more time, you can see that if I have the sine power 8x, okay, now this function can also be written as, or it is equivalent to sine x whole to the power of 8. Remember that if the power is written on the sine, cosine or the tangent, it means it is over all power. It is the power which is on the top of the whole function. So now you can see that this sine x, it is actually the inner function and the power always be the outer function. Now when you have to solve for the chain rule, so remember that according to the chain rule, you have to take the derivative of the outer function first and then take the derivative of the inner function. We are asked to take the derivative of a function which is written in the form of composite. So let's suppose there is a function x cube plus 2 whole power 3. Now this is a function which is composite function. Okay, so here you can see that this is the inner function and here is the power is the outer function. Now first thing is that you have to take the derivative of the outer function with respect to x. So outer function is power, right? So we have to apply the power rule. So what does the power rule says? that bring the power before the function, that is 3. Write the inner function as it is. Now power rule says that from subtract 1 from the power, so it becomes 2. After that, according to the chain rule, now take the derivative of the inner function. So inner function is x cube plus 2. Take the derivative. So I just put the dash on the tops to understand that I have to take the derivative. Now derivative of x cube plus 2. The derivative of x cube is what? 3x square. Okay, so this is how the whole chain rule works. So one by one, let's try to understand all the functions, and let's combine them with the basic rule of differentiation. So how does the power rule works? Here is the formula, and I will explain you with the help of examples. How to apply the chain rule? In order to understand this, first of all, label the inner and the outer function. So here is your inner function. The function that is written inside the bracket is your inner function, and this is your power. Okay, that is the outer function. Now, whenever there is a power, remember that power as an outer function, you have to apply the power rule. So if I write the basic power rule, it says that x to the power of n has, if you want to take the derivative of x power n, you will bring the n beside the x, write the x as it is, from this power subtract 1. So this is the power rule. Now how this will be connected with the chain rule? Bring the power in the shoulder, means over here. So first y changes into y prime because I am ready to take the derivative. Bring the power beside the function. Write the equation or the inner function one time as it is. From the power subtract 1, and now take the derivative of the inner function. So we will write the 5. The derivative of outer function, I will just copy it down. Now here I have a prime, which means I have to take the derivative of this function. With respect to x, bring the 3 here, apply the power rule, write the x from the power minus 1, that is 2, plus derivative of x is 1, that is a formula. Derivative of 2 is 0. That is all. So this is how the question we can take the derivative of the composite functions. How can we apply the chain rule on the composite function, which means a function carrying the inner and the outer function? The first thing is identify where is my inner function, which is in inner function. My inner function is inside the bracket, and the power will always be considered as the outer function. Since the outer function, now what is the formula that take the derivative of the outer function times the derivative of the inner function? This is the formula in a simple way for a chain rule. Okay, so since the outer function is your power, which means that you have to apply the power rule of differentiation. So what does the power rule says? That bring the power in the shoulder. First write y in y prime. Write the power in the shoulder. Write the inner function one time as it is, no change, because we are attacking only on the outer function. From the power in the power rule, we subtract 1, that is 99. Now write the inner function as it is because you have to take the derivative. So write the inner function as it is, and on the top write the prime, means take the derivative. Now before, write everything as it is, no change, because the derivative is already finished. Take the derivative of the inner function. So 3 times 2, 6x power 2 minus 3 times 2 is 6x from the power subtract 1. So we don't write the 1. Plus derivative of 6x is 6. Derivative of 1 is 0. So no need to write. This is your answer. Let's have a look on another question. So write the y prime. Inner function is the function which is written inside the bracket. The power will be your outer function. So you have to apply the power rule of differentiation, which states that bring the power in the shoulder. Write the inner function as it is, no change. From the power subtract 1, which will give you 18. Now write only the inner function which is written inside the bracket without the power. Put a prime on it. Now the functions which doesn't carry the prime will be copied as it is. Take the derivative of inner function. Use the power rule. 4 times 2 is 8x. From the power subtract 1. So we will get the 1. We don't write the 1 power. Plus derivative of constant multiple rule, that is 16x, changes into 16. And that is our derivative. Here is a question in which there is a radical sign. So first thing I will advise, whenever you look at the radical sign, convert into the power to make your life easier. So square root has a power half. Write down 7x square minus 4x plus 7 as it is. Take the derivative of the function, which means that bring the power before the function. Write down the inner function as it is. From the power we always subtract 1. So half minus 1 will give us negative half. Now write the inner function, which means only the bracket function as it is, and put a prime. In this start, here there is no prime. Now, but there is a negative power. So what you have to do, bring the shift the function, bring it into denominator to convert the negative power into positive 1. So look here, it's half, right? So 1 over 2, because 2 is already written down. Bring this function in the denominator, and on shifting the place, we know that the sign of the power converts. Now here take the derivative of this inner function. So 7 times 2, we can write here 14x. From the power subtract 1, you will get 14x minus derivative of 4x will be only 4. Derivative of sign is 0, so no need to write. Now either stop it over here or you can simplify more. How? You can take the common here. Look, 7 times 2 is 14 and 2 times 2 is 4, which means that the both terms have this 2 common. Okay, let's try. So if I take the 2 common, what is left from this 14x? It's 7x only, minus this 1 2 is outside, so only this 2 left. Why I did this? This is an interesting question. So what is the benefit of taking the 2 common? So this 2 will be cancelled with this 2. And this is your final answer. So either write it as a power half, the denominator, or convert it into square root. So it's up to you. Here is another question. Square root of x to the power of 4 minus 2x plus 4x squared minus 3. So what is our first step? To convert the equation into the power. Change the radical into power. So the power of square root is half. Please memorize these things. Now take the derivative, which means fx changes into f prime x. So what is the power rule? Here the function which is written inside the bracket, this is said to be the inner function and the power is the outer function. Apply the power rule, bring the half before the function, write the inner function as it is, no change. From the power, subtract 1. So half minus 1 gives us negative half. Now write the inner function, means only the bracket expression without the power, and put a prime on it. Which means that I have to take the derivative of the inner function. Now the first function has a negative power. To write it or convert it into a positive power, change the place of the function. We write the 2 as it is, this 2. This function is in the numerator. You bring it in the denominator, means write it beside the 2. And now the power could be changed into positive 1. Take the derivative of this one, power rule, 4 as it is, x from the power we subtract 1, minus derivative of 2x is 2, plus 4x square means 4 times 2 is 8, x from the power we subtract 1, and negative 3 derivative is 0. So again you can take the 2 common. Why? Because look at this, 2 times 2 is 4, 2 times 1 is 2 and 2 times 4 is 8. So what is common in them? 1, 2. So this has 2, here is 2, here is 2. So we will write the 2 as a common. What is left now? Now here left 2x cube minus here left only 1 and over here left 4x over, write down the denominator as it is, or you can write it in the form of radical. Now this 2 cancel with this 2 and that is your answer. So remember, if you want to succeed, you have to practice as much as possible the questions so that you can learn from your mistakes and avoid mistakes in future. What will happen if it is fifth root of something is written? We know that fifth root of something, it can be written in the form of x to the power of 1 over 5. So here we write the inner function as it is and put the power as 1 over 5. Now remember, I am not applying any calculus formula. I am just doing it algebraically. Now I am ready to take the derivative. So bring the power in the shoulder over here. Write the inner function as it is, no change. From the power subtract 1, it will give us negative 4 by 5. Write the function, inner function as it is without any change and put a prime on it. Now convert the negative power into positive. So change the position of this function. Negative 4 by 5 changes into 4 over 5. Take the derivative of this inner function. So apply the power rule, bring the 2 in the shoulder, x from the power subtract 1 minus derivative of 5x is only 5. Now you can clearly said that there you cannot take the common in the numerator, so that would be your answer. Another question, before you do it, understand that if I have something outside and some power inside, then in the exponential form, we will write in over out power. It means m top n time. So how can we convert or apply the algebra to convert this radical sign into the exponential form? We will write the inner function as it is, which is the function which is written inside the radical sign, and this index which is outside will be divided here, means in over out, 2 over 3. Now start taking the derivative. Bring the power before the function as it is. Write the function as it is, inner function. From the power subtract 1, so it will give us negative 1 over 3. Write the inner function as it is with a prime. Now complete. So 2 by 3. Bring this down, okay, to convert the negative power into positive power 1 over 3. Now derivative of x is 1. Derivative of 5 is 0. Now you can take, simplify, 2 times 1 is 2 over 3, and the rest you copy down. Okay, what will happen? What will happen if I have some function which is in the denominator? So let's see, this is the function. Okay, change your function, 1 over x minus 2 whole square. So whenever there is any function which is in the denominator and containing power more than 1, okay, more than 1, not 1, then you bring it up. When you bring this function up, of course, means 1 is written already on the top. You bring the function up, so the sign of the power will be changed. Now take the derivative. So negative 2 times 1 gives us negative 2. Write the inner function 1 time as it is. From the power subtract 1, which will gives you negative 2, negative 1, negative 3. Okay, write the inner function, only the function which is written inside the bracket as it is, and put a prime on it. Now here we have no prime, but there is a negative power. So write again in the denominator to convert the sign of the power. The derivative of x is 1. Now simplify, minus 2 times 1 is negative 2 divided by x minus 2 whole cube. Okay, again there is a power in the denominator, so bring it up. When you bring it up, 8 stay as it is. The function stay as it is. Don't change the sign of the overall function. Only change the sign of this outer power. So 2x square plus 3x minus 1. Bring this on the top. Plus 3 changes into negative 3. Now take the derivative applying the power rule of differentiation. Minus 3 times 4, 8. That gives you minus 24. Write the inner function 1 time as it is. From the power subtract 1, which means negative 1, negative 3, negative 1 gives you negative 4. Now write the inner function without any power and put a prime on the top. So you will get negative 24. Again here there is a negative power, so write it in the denominator but the sign of the power will be converted into 4. Take the derivative. 2 times 2 is 4x plus derivative of 3x is 3. Derivative of 1 is 0. Now you can't solve more than that one. So this is your answer.